This is High Fidelity. This is High Fidelity, the reproduction of all the original sound without addition, subtraction, or change. The first requirement for perfect sound reproduction is extended frequency range, a range which can encompass without strain or distortion, forceful lows, insistent highs. And complex ensembles. The delicate difference in timbre between a violin and a viola or a clarinet and a flute are lost when the upper frequencies are lacking. Whereas the true character of each instrument should be clear. Musical reproduction began with a frequency band of about 300 to 3,000 cycles, and quaint as it sounds today, it conveyed an intelligible impression of the score. Now we will extend that range up to 5,000. And down to 100 cycles. And up to 8,000 cycles. Then below 100. And finally, full range. Now let us turn the picture around and see what has been lost in these incomplete transmissions. The range above 8,000 cycles only. Above 5,000. Above 3,000. Here is what is lost at the other end of the spectrum, below 100 cycles. And the frequencies below 300 sound like this. Most of the music was in our original band of 300 to 3,000 cycles, but the color and character of the sound lies above it, the weight and impact below. If you consult a score and the musical instrument frequency chart, you will see that the fundamental musical frequencies of this music, played by bass and organ, are much lower than 3,000 cycles. But here is what happens when the component above 3,000 cycles is removed. Notice the difference. A piano, on the other hand, has less sound energy beyond 4,000 cycles, as this filtered example shows. The region below 300 cycles is indispensable. As compared with full range. That is a string quartet, a perfectly proportioned musical form. It would be spoiled by adding inappropriate parts. The bass would make it sound elephantine unless it were entirely rescored. A piccolo or cymbal would make it sound comical at the cost of its classic symmetry. In that, the musician has a lesson for the audiophile. While an extended frequency range is always the ideal, it is practical only if it is in balance with itself. Perfect high-frequency response can become wearisome if it is not supported by low-frequency power. Notice how that improves when we add the foundation. But a broad foundation and no top is also bad. That may sound agreeable momentarily, but with continuous critical listening it becomes ponderous and oppressive. When audio equipment is nasal, shrill, hollow, or thick, the possible causes may be several. Improper equalization of the recording characteristic may be responsible, or more frequently, acoustic peaks in certain regions. Here is a peak between 3,000 and 6,000 cycles which a faulty cutting head might produce. Listen to this peak between 8 and 1600 and you can recognize the cavity resonance, such as the mouth forms when pronouncing the vowels A, E, I, O, U. All these peaks are difficult to cure in recorded material, but especially in the middle region, as between 4 and 800. A peak between 1 and 200 often means improper bass compensation in a poor amplifier system or speaker cabinet resonance. When we smooth out these peaks, the material assumes its proper dimensions. Our ears are least sensitive at the ends of the frequency spectrum. If volume is reduced, the loss of bass is especially noticeable. At a normal listening level, the bass should now be inaudible. We will bring up the bass while retaining the level of the highs. The difference in level between what we can and cannot hear in this case is 9 dB. If we were to raise the middle range the same amount, this is how it would sound. That illustrates how much more sensitive our ears are in the middle than at the ends of the spectrum, and why we are unable to hear in its original proportions a musical score which has been reduced in volume. Conquering the acoustic spectrum is a Pyrrhic victory if it is done at the cost of distortion. If those cymbals sound like breaking glass instead of ringing metal, something is amiss. Violent percussive sounds impose the most serious strain on a pickup, amplifier, and loudspeaker. At the other end of the scale, we have the subtle relationships and delicate shadings of tone, color, and nuance which require precise values and immaculate transmission, as these dramatic chords. and soft plucked strings, and woodwinds. In Beethoven's Eighth Symphony, or again the suppressed nervous excitement in the finale of the same composer's Fourth Piano Concerto. The haunting, ethereal magic of Ravel's Rhapsody Espagnole. The instruments then must sound like themselves. They must have their full color, and they must stand clear and independent of each other. When an orchestra sounds like a kazoo, or a piano as if there were paper on the strings, harmonic distortion is responsible. Notice the difference. Distortion is most noticeable in sounds which are pure and intense: piano, flute, horn. Other instruments seem to absorb distortion products within the framework of their own rich, well-distributed harmonic fabric, as you will see from this contrasting instrumentation. The same amount of distortion is present, but it is better concealed by the acoustical structure of the strings and woodwinds. Sounds interfere with each other in various ways. Blasting, fluttering, and cancellation in the assertive high winds is a frequent form of intermodulation, for which there is ample opportunity in this energetic bit from Stravinsky's Pulcinella. It speaks well for any amplifier, pickup, and speaker, which can reproduce that cleanly. One of the most conspicuous examples of intermodulation distortion is the way in which a sustained low note will shake high notes. Listen for firmness in the treble. It should hold steady. Transient distortion is less easy to recognize, but its effects in listener fatigue and impaired fidelity are important. Notice the proportions of each piano note in regard to the initial hammer stroke and the persistence of the tone thereafter. If that sounds as I hope it does, you will be able to read the name on the letterboard. And it can only sound that good by virtue of excellent transient response. That signal is distorted, but it is also limited in frequency range, and for that reason less objectionable than it would be if wide range. Other disturbances which are troublesome in themselves and also in combination with the program material are leaking filter networks in the amplifier power supply, which pass alternating current hum. And unshielded or improperly grounded signal lines which have a roar of indeterminate pitch. Any of these conditions, external noise, laggard transient response, intermodulation, or harmonic distortion, damage the audio quality even though they may be unrecognized. That is a chord played by a full orchestra. Here are the musical elements and what they contribute to the entire product. The strings are the foundation of the modern orchestra because of their versatility and their well-organized harmonic pattern, which makes them a cohesive framework for the entire tonal design. The woodwinds add grain and color, and the brass, body and high brilliance. Now we start with the backstands and move forward. Brass, woodwinds, and then strings. This is the way the string section is put together, beginning with the basses and moving up to the first violins. The woodwinds, one by one, and then full. the brasses individually, then together. And when we put them all together, we have It is a very complex acoustical structure, but it can be resolved in terms of the pure sound waves, such as used for the frequency tests. A single note has no musical meaning. It becomes significant only when it is broken into rhythm. Contrasted with other notes. And joined with other intervals, such as fourths and fifths. Thirds and sixths have a softer character. And finally, when combined or contrasted with fifths and octaves, build up our conventional system of harmony. These and the other notes or intervals of our scale have their basis in the nature of sound itself, for most vibrating bodies tend to subvibrate in a systematic order, twice, 3 times, 4 times the fundamental frequency. It is the harmonics, their presence, intensity, and relation, which make tone color, and which require good high-frequency response, since they lie above the recognizable pitch frequency of the fundamental. It is the fundamental which gives the tone body and carrying power. If you rehear the orchestral score on the other side, which was cut below 3,000 cycles, you are hearing no fundamental sounds at all. The only standard orchestral instruments with a fundamental range above 3,000 cycles are the harp and piccolo, and of course the piano and organ. The piano has great development of its fundamental frequencies and substantial carrying power. While the harpsichord has little or none, but its rich harmonics give it superior brilliance and blending properties. Warm, glowing, musical sound is a product of acoustic reverberation. Of what you now hear, over 90% reaches the microphone by reflection from the walls, ceiling, and floor, and less than 10% is direct. The studio acoustics is therefore a mathematically large and an aesthetically important part of sound on a record. We can hear reflected sound either as a persistence or as a repetition of the direct sound. A smooth persistence of sound without separate repetitions is known as reverberation. A sound repeated after an interval and heard as a separate sound is an echo. By adding repetitions, it is possible to simulate acoustically reflected sound. Here is an artificial sound reflection 1/3 second after the original. As we shorten the interval to 1/10 of a second, we are approaching the illusion of acoustical reverberation. But the telltale repetitions which follow any abruptly terminated note explain why there is still no substitute for the continuous reflection of uninterrupted surfaces and the smooth persistence and gradual decline of sound essential to such a Promethean cadence as this. Dramatics need a large stage. A music of cultivated elegance, on the other hand, would be quite out of place in such a framework. Whereas, if we leave just enough reverberation, the voices come into focus without losing their luster. The acoustical framework is therefore inseparable from the complete musical entity, regardless of the tempo or the immediate objectives of the composer. The recordist's first task must then be to fit the studio to musical requirements. He may have an intimate chamber group, as in the Bach-Brandenburg concertos, or the more formal orchestra of Mozart. The orchestra of Haydn and Beethoven assumed new, dynamic dimensions, which were to reach a climax in the scores of Wagner, Brahms, Strauss, and their followers. Thus, proper studio acoustics is the first requirement in good recording. The second is the right presence and proportion of the tonal elements, which depends in turn on the number, choice, and location of microphones. The farther the microphone from its subject, the mellower and more reverberant the sound. The closer, the greater the presence, and the more vivid the tone quality. No one could mistake those instruments, though he might mistake the orchestra for a small one playing in a little studio. To retain all the color, with the breadth and perspective of the original, summarizes the recordist's art which has created a new worldwide audience for each recorded performance.